Hi guys, today we're going to do a little review on electrochemistry. We're going to start out with the basic term of what is electrochemistry, so let's write that out here, electrochemistry. And basically, electrochemistry is the study of redox reactions that produce or require an electric current. So, let's just put this in simple words, the flow of electrons is associated with electricity. Alright, so this topic is more or less conceptual, so it's really important to understand how everything is working on a conceptual basis before we perform mathematical calculations. So in this chapter, we'll be going over oxidation and reduction. Oxidation reduction equations go as a reaction in which electrons transfer from one atom to another. So atoms that lose electrons are oxidized, and atoms that gain electrons are being reduced. So one more time, atoms that gain electrons are being reduced, atoms that lose electrons are being oxidized. Just understand and think back to Chem 1 and what it means, what it looks like when an atom loses electrons. It's going to be +1, -1 on top. Just try to reconsider that. If you need to go back, look it up on Google, just so these next problems make a little more sense, which we're going to do on the next page. Let's try this out. We have 2Na solid plus Cl2 gas equals 2NaCl minus solid. Let's see, here we go. We got what is going to be oxidized and what is going to be reduced. We have Na right here. Let me just get my pointer out. Yeah, we have Na right here. We have NaCl, oh, I'm sorry, I've apologized. It's Na plus right here, Cl minus. So we have Na plus. So what's happening there? It's losing electrons. So you write that as this. Na is Na plus 1 electron, which represents losing an electron. And this is oxidized. Now let's look at this one. Cl2 plus. We have Cl2, minus 1. So we have electrons being gained, and you get 2Cl minus. So this is reduced. So let's just do a little review. Oxidation occurs when the number of elements increases, an element loses electrons, a compound gains oxygen, or a compound loses hydrogen. Reduction occurs when oxidation number of elements decreases, an element gains an electron, compounds lose oxygen, or compound gains hydrogen. So, in simple terms, oxidation occurs when an atom's oxidation state increases during a reaction. Reduction occurs when an atom's oxidation state decreases. Alright, so obviously they're not all going to be simple like this, so let's go over some of the rules. Alright, I didn't feel like writing out all the rules back out here, so if you guys want to pause this, read them over. These are the basic rules, and I'll be explaining the rules as we go over problem solving. We have over here rules for assigning oxidation states. Free elements have oxidation states of 0. So like Na alone is 0, Cl2 alone is 0. Even though we have that subscript right there, it's still going to be 0. Monoatomic ions have an oxidation state equal to the charge. So Na is +1, Cl is -1. Now if you're confused and you remember how to find the charge, you just look on the periodic table. 1 and 2 is 1 and 2. Like the column 1 and 2 would be 1 and 2. Then obviously you should remember the rest because of Chem 1. Number 3, the sum of the oxidation states of all the atoms in a compound is 0. The sum of the oxidation states of all the atoms in a polyatomic ion equals the charge on the ion. NO3 to -1 would be -1. Alright, so group 1 metals have an oxidation state of +1 in all their compounds. Group 2 metals have an oxidation state of +2. That's similar to look at the periodic table. It's not that hard. Now, there's some other rules, but for the sake of the problems we'll be solving, these set of rules right here will be sufficient to solve for all the problems that we're going to do. Alright, let's do a couple problems on the next page. Alright, so we have Fe2O3 plus CO equals 2Fe plus CO2. So we have to assign oxidation states to every single one of these. Let's start with this guy right here, Fe2O3. How are we going to do it? Well, we know that the oxidation of oxygen is going to be -2, and you get that by looking at the periodic table. So right here, write -2. -2 times 3, since there's 3 oxygens, becomes -6. And now, Fe2O3, you could pretend there's like a little plus 0 here. It has to equal 0. So, what do we have to have right here for it to equal 0? We have to have +6 to equal 0. But there's 2 of these, so it's going to be +3 for Fe2. Alright, now let's look at this next one. We have 3CO. We're going to ignore the stoichiometric 3 right now and just focus on the C and the O. O, as we just said, was -2, right? -2. So this is -2. This has to equal 0 because pretend there's an imaginary +0 up there. Oh, this has to become +2. So you get +2. Alright, Fe. Fe is a free element, so Fe is going to stay like this, 0. 3CO2, again, -2, -4, +4, +4. Now we have to figure out what's being oxidized and what's being reduced. We have here Fe2, so we have Fe in the beginning that has +3. And then in the end, Fe has 0. Alright, so what's going to be oxidized, what's going to be reduced? We're going to have Fe2 being, So Fe is being reduced, right? Because it's losing electrons, it's gaining electrons, so this would be reduced. Now, remember how we had conjugate acids and conjugate bases? So we're going to have, I spelled that wrong. Anywho, pretend that's spelled right. I don't feel like reducing it. From fixing it. So this is going to be, Fe2O3 is going to be an oxidizing agent because it's being reduced. Remember, a base and a conjugate base? Similar concept. So this guy, Fe2E2O3, is equal to the oxidizing agent. Obviously, now we have C plus 2 becomes C plus 4. So that's going to be the oxidized, which means oxidize. I can't spell today. Oxidize. So it's the reducing agent. Alright, and C, we have O minus 2 up here. We have O minus 2 up here. And we have O minus 2 here, O minus 2 here. O, nothing ever happens to, so it stays the same. Alright, this will be our last one. We have 3S2 minus plus 14H2 plus CrO7 minus 2 equals 3S plus 2Cr3 plus H2O. Alright, so what do we do? This has a lot of rules in here, so that's good. First off, this one right here, 2 minus. So we know if it's a 2 minus, the oxidation on this state has to be -2. So -2. 14H plus, it has a 1 plus, so this has to be +1. O7, now this has a -2, so whatever these oxidation states have to equal -2. We know that oxygen is -2 times 7 is -14. What plus -14 equals -2? 12. So we know that, I apologize, this is Cr2. So Cr2, O7, has -14, 12. So what do? We have to make sure this is +6. So that's what the Cr2 would be, because it has to be 12 minus 14 equals -2, and there's 2 Crs, so all the rules are met. So we have 3s, that's a free element, so this is 0. Cr3 plus. Again, we know that's just going to be 3 plus. Then we have H2O. We have -2 here, which would be -2. So this has to be +2, and there's 2 of them, so it has to be +1. So what was oxidized and what was reduced? Let's start off with this. We have S2 minus to S0. So this was losing electrons, right? So now we have it's being oxidized. So it's the reducing agent. Alright, the next one we have H plus equals H plus, so nothing. But we have Cr2 plus 6 equals Cr plus 3. So it's losing electrons, so it gets reduced. So it's the oxidizing agent. Alright, so that's the basics of it. Hopefully we all understand that, and if not, we'll go over more during our lecture in class.